Our topic is we'll solve the question of past papers, that is May June 2019, and this is the continuation of the topic that was conversion of bases, and we have discussed this thing in the previous video as well. So let's start understanding the latest question of past paper. Well, this question is a long distance running race uses an electronic counter that counts each competitor who finishes the race. The count is stored as a 12-bit binary numbers register. So the denary value of the counter is displayed on the screen above the finish line. The screen currently displays 0039. So this is the denary value, the decimal value given, and it's asking a question. State the binary value that is currently stored to display the count shown. So it means, so you'll have to convert in the binary format, and binary format, for the binary format you are very much familiar with how to convert this 39 in binary. So for that we'll use the same pattern as well, like 1 2 4 8, something like this. 1 2 4 8 16 32. So plus 4 plus 2 plus 1, it will become 39, and rest of the values will be off. So this is your answer in 8. It's not in 8-bit format. At how many bits you have used? 1 2 3 4 5 6. So question was asked that you are required to write the answer in 12-bit binary numbers. So 12-bit register will have to write the zeros on the extreme left side. So I'm sure it is clear, and now look at the answer. So the answer is 111. See this one. The whole answer is same as this one, 111001, and it was the answer we have calculated, but it has a leading zeros as well. So the whole one is 12-bit register now. So this answer is required, and you are required to show the working as well. So it is better if you have shown the working like this. So I'm sure it is clear. Now look at the next question. The next question, it is asking, more competitors cross the finish line and the screen now displays this value. So in the beginning it was 39, now it has become 350. So how you will write? State the binary value that is currently stored to display the shown count shown. Fine. Further we can see this, how it will become 350. The same pattern will be used as we have done here. So you can see this one, 1 2 4 8 16 32 64 128 256. So you will, whenever you will add up the values with one, this one, this one, and these fours. So we can say it is 1 2 4 8 16 32 64 128 and 256. So if you add up the values 256, because this bit is on, and you add up the value that is 64, and then you will have to add the value 16, 8, 4, 2, that's all. So it will become 350, and it was our requirement. So I'm sure this question is clear. So all these bits are ones, so that's why I have added, and on the left side we'll add up the leading preceding zeros as well. So this is, the answer is in 12-bit. Always will have to we are bound to give the answer in 12-bit register. I'm sure it is clear. And we have the another part of this question as well. At the end of the race, the binary value stored is this. So what you will do give the denary value that would display on the screen at the end of the race. Show your working. It means the same pattern will have to write with the help of 1, 2, 4, 8, 16, 32, 64, 128, 256, and 512. Most probably it can increase as well. Like this one is for 1, it is 2, it is for 4, it is for 8, it is for 16, it is for 32, it is for 64, it is for 128, it is for 256, it is for 512, and this will be 1024. So how you will solve the answer? Whatever the bits are on, 1024th bit is on, 512's bit is on, and then we have 128th bit is on, 64, and these are off, and this one is 4 and 2 and 1 as well. So you will see the answer, that is, if you add up the ones bits you will get 1735. So this is your answer. The next topic will be the uses of hexadecimal number system in computer format. So we'll discuss those topics in detail. So stay with us. Thank you very much.